but thank you all for coming. Um, so today first thing we're going to do, bravo on the quiz. Most of you did very, very well on the quiz. I will release those results right after class today. I think the average was an 83. Many of you got 100. So there were a few of you that didn't do well. If you didn't do well, please let me or a tutor or somebody know, because these fundamental concepts that we're going over right now are going to be building blocks for going forward. Okay, so if you don't understand this stuff, we need to get it straight. Okay, but most of you did really, really well. I was very pleased. So the first thing we're going to do is go through the quiz. So here we are. All right. Can you guys see the quiz?
Yes.
Okay, good. Now let me see if I can write on it. Let me write on. Okay, yes, I can write on it. Okay. So this may or may not be in the order that you took it, because I randomized the questions, so you may have gotten them in a little different order, but that's okay. This one hopefully was very easy because we talked about it a lot in class. A drug's clearance is dependent. So the clearance is dependent. So what do you think clearance depends upon before we go forward? What does clearance depend upon? Well, we haven't really learned it yet, but I'll tell you it's blood flows, it's enzyme activity, it's how many receptors are, or how many carrier sites are available, etc., things you haven't learned yet. So a drug's clearance is not dependent upon the elimination rate constant, is it? But if I were the answer here is false. If it were the reverse, if we said the elimination rate constant is dependent upon clearance, is that true?
Yes.
Yes, absolutely it is. So a drug's clearance is not dependent upon K, but K is dependent upon clearance and what else? Volume, right? Are y'all good with that? What I want you to make sure you understand is you should think of the relationship in this order, even though we do use clearance is equal to V times K to calculate clearance. Sometimes you don't want to think that clearance is determined by volume and K. It is not, right? K is determined by clearance and volume. It's just a rearrangement of that equation. Is everybody good on that? Is everybody understanding the relationship and making sure the relationship is understood? What determines what? Okay, good. So your patient George is taking 250 milligrams every 6 hours of drug X. Okay, so if he's taking 250 milligrams every 6 hours of drug X, what's his dose rate in amount per day? In milligrams. How much is he getting per day? 1,000 milligrams per day, right? Is everybody good with that? And his dose interval, tau, is 6 hours. I'm having trouble writing. Okay? The CSS average is double what we want it to be, but the peak to trough ratio is in the desired range. Okay, so if the CSS average is too high, what do we control in that relationship? Well, we know CSS average is determined by drug in over drug out, right? So if this is too high, what can we control? We control dose rate. We don't control bioavailability or clearance. So what are we going to do? We're going to decrease the dose rate, aren't we? How about our peak to trough ratio? Remember, our peak to trough ratio is determined by, if we simplify it, e to the k tau. And K is determined by clearance over volume, right? So clearance, volume, and tau, what do we control there? We control tau, don't we? So if the peak to trough ratio is okay, though, we don't even need to worry about this. So we're going to leave the dose rate or tau alone, but we're going to decrease the dose rate. So if we want to go from 1,000 milligrams per day, what are we going to go to? We go to half or double. We're going to go to 500 milligrams per day, but we're still going to give it every 6 hours, right? So we already know this is 6 hours. What are we going to do? We're going to give 500 milligrams Q6. So 500 divided by 4 is 125, isn't it? Is everybody good with that? Okay, I'm going to assume yes. This is going to be really dull, isn't it? Whew, you guys have to participate a little more. This is going to be rough. Because we got to do this tomorrow too, unfortunately. All right, so choose the dependent variable in this equation. What's dependent mean? It means that the others will determine, or it depends upon the other things. So and I don't think the equation was given. Oh, shoot. I don't remember what it said. Let's see. It was probably this, I'm guessing. Shoot, I'm sorry I didn't copy that for you. So what's the dependent variable in this equation? Well, we want to say clearance because our brains think whatever is here is the dependent variable, but it's not in this case because we know clearance is not determined by dose rate, it's not determined by bioavailability, it's not determined by CSS average. Clearance isn't determined by any of these. But we know if we rearrange it to the way we should be thinking about it as far as dependency, the dependent variable is CSS average. So the answer here is CSS average. Okay, your patient Henry is on 1 gram of cefazolin every 6 hours. Okay, once again, 1 gram every 6. So the dose rate is 4 grams per day. The dose interval is 6 hours. Suddenly goes into sepsis. This is a problem we actually did. Acute renal failure, so decrease in clearance, right? If cefazolin is cleared by the kidneys, how do you expect to need to alter his dosing regimen? Assume everything should be double or half as we did in class. Okay, so a decrease in clearance, what's that going to do? Well, the first thing we want to ask ourselves is, do we want to make a change in dose rate? Well, how do we decide? We look at CSS average. So CSS average is determined by bioavailable dose rate over clearance, right? What we know is that the clearance has decreased. Therefore, our CSS average is going to go up. So what do we want to do? Well, the only thing we control here is dose rate. We're going to decrease dose rate, aren't we? Okay. And how about peak to trough ratio? Or I'm sorry, how about dose interval? Do we want to change dose interval? How do we decide? We look at peak to trough ratio. If we decrease the clearance, the slope of our line is going to get flatter, right? And we know that because K is equal to clearance over volume. If there's a decrease in clearance, K will decrease, won't it? If K decreases, our peak to trough ratio decreases. So how do we get our peak to trough ratio to increase to what it was before? We extend the dosing interval. So we give it less often and we increase the distance between our doses. So instead of Q6, we're going to go to Q12, right? Because we're going to increase tau. And we want to decrease our dose rate. So we're going to go from 4 grams to 2 grams per day. So if we're going to 2 grams per day and we're going to give it every 12 hours, what's our new dosing regimen? Well, if we're giving 2 grams, we're going to give it twice a day, so we're going to give 1 gram every 12 hours. All right, am I boring you now? All right, whoopsie, whoopsie. Leaned on something. Choose the dependent variable in this equation. What's the dependent variable here? Is it volume? It's what our brain wants to tell us, isn't it? Is volume dependent upon clearance? Well, no. Is volume dependent upon half-life? No. Here, half-life is the dependent variable, right? Half-life is equal to 0.693 volume divided by clearance. So our dependent variable here is half-life, isn't it? I think those were the most missed questions, were the dependent variable questions. Could be wrong about that though. All right. After each midterm, so here's a syllabus question. Hopefully this was easy. After each midterm examination, there will be a learning session scheduled. This session is required for those who score less than 73, which means you failed the exam. So it's required for those who score less than 73 that want to qualify to take the remediation exam. But it's optional for others. Well, yeah, that's true. Let's read the other ones. The session is optional for all students who want to take the remediation exam. No. If you failed the exam, you have to do the learning session. It's required for all students. No. All right. So if you fail the exam, you have to do the relearning session in order to qualify to take the remediation for that exam. Let's say if you failed the first exam and you don't go to the learning session and you do fine on the second exam, you can't take the first exam as your remediation exam. You could take the second one and try to improve it more to help your grade, but you can't take the first one without attending the learning session. All right. The student may remediate one midterm exam. That's right. You can only remediate one. The exam score will be averaged with the first attempt. Nope. We'll take your highest score. So that's false. All right. Your patient is on 500 milligrams of Glonbite, Glonibix. Do you know that there's a website that will make up drug names? I use that for these tests because I think it's fun. It's called like Drugomatic or something like that. Anyway, your patient is on 500 milligrams of Glonibix every 12 hours. All right, so again, the dose rate is 1,000 milligrams per day. They're getting it every 12 hours. They start a new formulation of Glonibec. I can't say it anyway. That has a decreased bioavailability. How would you expect to need to alter their dosing regimen? Okay, same problem, but different issue, right? So first thing we're going to ask ourselves, do we want to make a change in dose rate? Well, our dose rate, we need to look at CSS average and see if it's where we want it to be. Well, we know that CSS average is determined by drug in over drug out. So what's happened here? We've had a decrease in bioavailability. So our bioavailability decreases. So what's going to happen? Our CSS average is going to decrease. What do we control here? Well, we control the dose rate. So we're going to increase the dose rate to make up for that decrease in bioavailability. How about dose interval? When we're looking at dose interval, we look at peak to trough ratio. Peak to trough ratio is determined by K, which is determined by clearance and volume, and what we choose, which is the tau. So has clearance or volume changed? Not that we know of. And dose interval we control. So we can leave this alone, can't we? We're going to leave our dosing interval alone. We're going to still give this every 12 hours. But now we were giving 1,000 milligrams a day. We want to increase our dose rate to 2,000 milligrams per day because we're going to increase our dose rate. We're still giving it every 12 hours. So the new dosing rate is going to be 1,000 milligrams every 12 hours. Everybody good? So we went from 500 milligrams every 12 hours to 1,000 milligrams every 12 hours. All right. A decrease in volume of distribution would be expected to cause what? All right, a decrease in volume of distribution. Will it decrease clearance? No, because volume does not determine clearance. A need to decrease the dose rate. What's dose rate? We will decrease the dose rate if there's been an increase in CSS average, right? Is CSS average determined by volume? No. So we're not going to probably need to mess with the dose rate, are we? Will it cause an increase in CSS average? Why did I put that there? No, because CSS average is not determined by volume, is it? A need to decrease the dose interval. Well, dose interval, let's see, is determined by K and tau. We control tau, but if our volume decreases, our K will increase, right? We're going to get a steeper slope, and we're probably going to need to decrease our dose interval. So yes, this one is true. And one more of these. Okay, your patient's on 500 milligrams of Jetlor every 12 hours. So your dose rate, hey, Fiona, stop. It's okay. Is 1,000 milligrams per day. Sorry. Just going to be a few minutes here until it's okay. It's okay. The patient has a drug added to their regimen that displaces Jetlor from binding sites, resulting in a decrease in the volume of distribution. So what we've got is just what we just talked about, right? A decrease in volume of distribution. So assume everything should be double half. The new dosing regimen should be what? Okay, so the dose rate they're getting now is 500. The tau is 12. So do we want to make a change in dose rate? What do we look at? CSS average. CSS average is bioavailable dose rate over clearance. Has there been a change in volume? Or I'm sorry, there's been a decrease in volume. So will CSS average change? No. So no change in CSS and in dose rate because we don't expect the CSS average to change. What about peak to trough ratio? If we decrease the volume of distribution, what's going to happen to K? K will get larger, right? You're going to go from a flatter to a steeper because it's more available to those clearance organs to be eliminated. So it's going to take less time to get eliminated. Your K will increase, and you're going to need to decrease your dosing interval to accommodate that larger peak to trough ratio. You're going to want to chop it up into more doses. You're going to give it more often. Your time between doses is going to decrease. So we're going to go to 6 hours here. So instead of giving it every 12, we're going to give